Section 5.1, Day 2. We're going to spend today working on solving more exponential equations. Today, though, our exponential equations are going to be a little more complex. They're actually going to be looking like a quadratic equation. Kind of fun, and they get more fun as the days go on. So, as we're solving an exponential equation, today, what I want you to notice and make sure is that when we look at these exponents, this 2x and this x, that we have a 2-to-1 ratio. So that this exponent here is twice this exponent here. If that is, it's going to be in the form of a quadratic equation. Remember, a quadratic equation might look like something like x squared minus 5x plus 6 equals 0. Notice when we solve this kind of equation, we also had that 2-to-1 ratio. We had an exponent of 2 here, and the exponent here is 1. So how can we solve this equation? I think it's easiest to do kind of a substitution to get it more in what we like and what we have noticed before and being able to solve before in a quadratic. So what can I do with this? If I take a variable, y, it doesn't have to be y, it can be any variable we want, and I let it equal that middle base with the exponent. So y equals 3 to the x. And that's just arbitrary mathematics. We can let anything equal anything as long as we allow it. We have y as a variable is going to equal that 3 to the x. So then I know that y squared, if I square both sides, then I get 3 to the x squared. I multiply the exponents through my exponent rules, and I get y squared equals 3 to the 2x. So now, looking at this equation, oh, I don't have 3 anymore. 3 to the 2x is y squared, isn't it? 3 to the x was y, so I have minus 12y plus 27 equals 0. This is now a quadratic equation. I can go ahead and solve that equation. To solve that, I can factor it. So I have y minus 9 and y minus 3 equal to 0. I can go ahead and set each part equal to 0 and solve for y. So y equals 9 and y equals 3. We're not interested, though, in what y is. We want to know what x is. So we need a relationship. Well, we know that y equals 3 to the x, doesn't it? So 3 to the x equals 9, and 3 to the x equals 3. From yesterday, we can go ahead and solve this equation. We can get a common base. So 3 to the x equals 3 squared. So x has to equal 2. Over here, 3 to the x equals 3. If there's no exponent, we know it's 1. So we know that x has to equal 1. So just like in a quadratic equation, we had two solutions. In a quadratic equation that has exponential variables, we're going to have two equations as well. This is a little bit of work. If you want to think of this as a quadratic equation and be able to factor that, you could factor this into 3 to the x and 3 to the x. So 3 to the x times 3 to the x gives us 3 to the 2x. Our 27 is minus 9 and minus 3. That's going to multiply to give us negative 9 times 3 to the x and negative 3 times 3 to the x. Added together gives us a negative 12 times 3 to the x. So I get 3 to the x minus 9 equals 0, and 3 to the x minus 3 equals 0. I can go ahead and solve both of these equations. 3 to the x equals 9, so x has to equal 2. And 3 to the x equals 3, so x has to equal 1. So if you're able to factor with variable exponents, which we've talked about in the past, your life does become a little less hectic and you can get through the work a little easier. If you don't like factoring with the variables and the exponents, which a lot of us don't, that's okay. You can come over here and do a substitution, make it look like a quadratic, and then solve from there. And we'll do a couple more examples. I will use the substitution method for you. I think it's a little easier for most people to see. If you want to work on the factoring of it with the variable exponents, by all means you can. So I notice I have a 2-to-1 ratio. This is twice as much as this exponent here. So I'm going to let y equal that middle term, or that second number with the exponent. So that makes y squared equal 2 to the 2x. So notice I can do a substitution. So I have y squared minus 4y plus 4 equals 0. I can go ahead and factor y minus 2, y minus 2. That's kind of nice because I just get y equals 2, don't I? So if y equals 2, I know that 2 to the x has to equal 2 as well. And then x would have to equal 1. In our next equation, our third equation, I guess, for the day, again, we have that 2 to 1 ratio. We have 4x divided by 2 gives us 2 to the x, or 2 to the 2x times 2 gives us 4x. So let y equal, again, that middle term, y equals 3 to the 2x. So y squared will equal 3 to the 4x. So I got the equation y squared minus 6y minus 27 equals 0. I can go ahead and factor. So I get y minus 9 and y plus 3 equals 0. Go ahead and solve. I know that y equals 9 and y has to equal a negative 3. Replace my y with 3 to the 2x. So 3 to the 2x equals 9. 3 to the 2x equals a negative 3. Here I can go ahead and find a common base, which is 3. So 3 to the 2x equals 3 squared. My exponents have to be the same from yesterday, so x has to equal 1. Now let's think about this one over here. 3 to the 2x equals a negative 3. There is no way that I can take a number to an exponent to get a negative value. So whenever we have a number to an exponent equal to a negative value, we know that there's going to be no solution there. So our only solution in this case is going to be x equals 1. One last page here for us. Again, same process, same type of problems. We're going to see that 2 to 1 ratio again. We're going to let y equal a second term with the exponent. And then y squared is going to equal twice that exponent, so that 4x. So I can write this as 5y squared. Notice that 5 doesn't go away. That's a coefficient. We're only changing that 5 to the 4x to y squared. So we have 5y squared plus 24y minus 5 equal to 0. I can go ahead and factor. So we have 5y and y. We're going to add 5 and subtract 1 equal to 0. Solving for y, I get y equals 1/5 from the first equation, and I get y equals a negative 5 from the second. Go and replace my y with 5 to the 2x, so 5 to the 2x. We had this yesterday, this 1/5. We can bring this 5 to the top, so we have a common base by taking it to the negative exponent. So 5 to the 2x equals 5 to the negative first. So now my exponents have to equal, so x will equal a negative 1/2. Over here, replace the y with 5 to the 2x, so 5 to the 2x equals a negative 5. Again, just from the last example, we cannot take a number to an exponent to make it a negative value. So there's not going to be any solutions from that portion. And we just get x equals negative 1/2. Last but not least, we have 3 to the 4x minus 36 times 3 to the 2x plus 243. So we're going to let y equal that middle term. And then y squared will equal 3 to the 4x. So here we have a y squared minus 36y plus 243 equals 0. Well, if I take 243, I can do a little bit of math here. But 243 is 27 times 9. So we have y minus 27 and y minus 9 equals 0. Go ahead and solve for y. So y equals 27 and y equals 9. Again, we know that y equals 3 to the 2x. So 3 to the 2x equals, since I know my base has to be 3, I know 3 to the third is 27, so I can go ahead and change that. And 3 to the 2x equals 9 is 3 squared. Go ahead and set my equation, or my exponents equal to each other. 2x equals 3, so x equals 3 halves. And here, 2x equals 2, so x equals 1. And that gives us our final answer. So there's an example, several examples of solving exponential equations that are in a quadratic looking form. If you have questions, please let me know. Good luck and enjoy.